Alright guys, so in this lesson we're looking at the sum and product of the roots of a quadratic equation. Now this is going to be a long one, so there's going to be 2 videos because I can only do a maximum of 15 minutes. So you'll need to watch both. You can watch one and do the start of the exercise and then watch the second one to finish it off if you like. It's up to you. But to start with, I want to consider the equation x squared minus 5x plus 6 is equal to 0. This is one that's pretty easy for us to solve. You should be able to tell me that the factors for 6 are 3 and 2, and that's what's going to give me the negative 5. So it's x minus 3 and x minus 2 gives me 0. So x has got to be equal to 2 or 3. Now, consider that solution, 2 and 3, and look back at the equation we started with. What that's telling us is that this number here is the sum of the roots, that's the 2 plus 3, and this number here is the product of the roots. So that was one of the methods we could use to factorize these. You found the factors for the product that would make the sum, and we're going to use that now. So the roots of our equation here are 2 and 3, and the sum of those roots ended up being 5, and the product of the roots was 6. So to generalize that idea, then what we say is that if the roots of a quadratic are, you'll see here we use alpha and beta. That's the convention. So the roots of a quadratic are alpha and beta. And if we want to work out what that means for our equation, we go through and we say, well, we know that if it's alpha, then x minus alpha is a factor. And if one's beta, then we know that x minus beta is our other factor. So when I expand that, we get x squared minus alpha x minus beta x plus alpha beta, which is x squared minus alpha plus beta, or the sum of the roots, and then plus alpha beta, the product of the roots. So the way this is used is like this example. So if they tell you what the roots of an equation are and they want you to find what the equation for the quadratic is. So we go back to that equation that we just said, the x squared minus alpha plus beta x and then plus alpha beta is equal to 0. And we look at our numbers. So the sum of the roots, alpha plus beta, is 5 plus negative 2. So we end up with x squared minus 3x. And the product of the roots, is going to be negative, so we're going to get negative 10 is equal to 0. So it's another way of finding the equation if they're given the roots. If we get away from a monotonic quadratic, which means that the coefficient of x squared is no longer 1, so if we go back to the general form of a quadratic, ax squared plus bx plus c is equal to 0, then the sum of the roots, using what we just looked at, the sum of the roots ends up being minus b over a, where b is the coefficient of x and a is the coefficient of x squared, and the product of the roots ends up being c over a. So there's a few ways they'll ask you this, and I'll go through some examples here, but you must remember those formulas. So the sum of the roots, alpha plus beta, is equal to minus b over a, and the product of the roots, alpha beta, is equal to c over a. If you don't remember those, you can't do anything in this question at all. Okay, so highlight them, put them on a flashcard, do something so that you will remember that formula. So looking at this example, for 2x squared minus 9x minus 18 is equal to 0. So we've got our a is 2, our b is minus 9, and our c is minus 18. If they then say, well, what is alpha plus beta? And this is generally the way the question will start. It will ask you for alpha plus beta, and then it will ask you for alpha beta. So the sum and then the product, because you will then use them to work out the other parts. Okay, so the sum of our roots for this one is going to be minus b over a, which in our case here is going to be 9 over 2. Okay, and the product of our roots, well, that is equal to c over a, which is negative 18 over 2, which is negative 9. Okay, so they're the two really basic ones. After that, you have to start looking at what they've given you and try and manipulate it so that you either operating with the sum, alpha plus beta, or the product, alpha beta. Okay, so looking at our next one, alpha squared plus beta squared. The problem that we have here is that we know what alpha plus beta is, we know what alpha beta is, but we don't know what alpha squared or beta squared is. So what I have to do is look back at my alpha plus beta or alpha beta and figure out, well, how can I make alpha squared plus beta squared? Okay, so over on the side, over here, we're just going to start thinking about, well, how can I get that? Okay, so if I say, well, I'm going to have to square a term. So if we look at alpha plus beta all squared, then we're going to end up with alpha squared plus 2 alpha beta plus beta squared. And that gives us our alpha squared and our beta squared, but we've got this extra term of plus 2 alpha beta, which we don't need. So what I do is then subtract 2 alpha beta from that. So if I go, well, okay, well, let's do alpha plus beta all squared minus 2 alpha beta, well, then I get alpha squared plus beta squared. Yeah? So coming back to here, we know that alpha squared plus beta squared is equal to alpha plus beta, so the sum of the roots squared, minus 2 alpha beta, so minus 2 times the product of the roots. Now, alpha plus beta, we worked that out in part A, so that's 9 over 2, and I need to square that. And then I need to subtract 2 times the product of the roots, which we worked out in B, to be minus 9. And then you just work out what that's equal to. So in this case, we end up with 153 over 4. You can give it as a decimal, but it's really not necessary. The fraction is fine. So you have to look at your sum and product and figure out how can I manipulate that to look like what they're asking me to. And it really is practice, guys. Once you've done these over and over again, you start to pick up the patterns. So if we have a look at the next one, we've got 1 over alpha plus 1 over beta. Now, I don't know what alpha or beta are, so I can't work it out directly. But what I can do is simplify these into one fraction. And if I do that, then my common denominator is now going to be alpha beta, which is the product of the roots that I do know. So 1 over alpha, I needed to times that by beta to get the alpha beta, and 1 over beta needed to be multiplied by alpha. And now I've got the sum of the roots over the product of the roots, and I know those two things. So the sum of the roots is 9 over 2, and then it's all over negative 9. And so we get 1 over alpha plus 1 over beta being equal to negative a half. Okay, so the next example is fairly complicated. What you need to do is remember that we're trying to get either alpha plus beta or alpha beta. So having a look at this, we've got alpha beta squared plus alpha squared beta. Go back to your algebra, guys. What do we do if we're trying to solve something like this? Well, the first thing we would do is factorize. So I've got a common factor of alpha beta, which is wonderful because that's the product, and I do know that. And then if I take out alpha beta, well, I've got a beta squared, so that leaves me with beta, and I've got an alpha squared, so that leaves me with alpha. And look at that, we've got the sum of the roots. So then it's just substituting in what we did in part A and B. So alpha beta is negative 9, and alpha plus beta, which is the same as beta plus alpha, is going to be 9 over 2. And so therefore alpha beta squared plus alpha squared beta is equal to negative 81 over 2. Now, there are a lot of different ways that they can ask you to use your sum and product, but it really is just picking up on a pattern. So once you've done a bunch of these questions, it becomes second nature. So I would suggest you do a lot of repetition of this stuff, and if you do, you'll get quite comfortable with it.